But this is just fun to contemplate. Just is. Whether you believe in God or not, this stuff is straight up fun. So. Hi folks, welcome to the channel, Thinking Theology. I'm Don. I just review, react to, analyze, assess, talk about theological things. I'm not pro-theology, I'm not anti-theology. I don't care if you're an atheist, Christian, Jew, Muslim, that doesn't faze me in the least. But I do like discussing things that relate to the universe, whether, where the arguments are constructed that suggest that God might be there, where the arguments are that suggest that there's no such thing, that mankind we're very creative and we've come up with this idea that there must be something bigger than us that created everything. Either one, there's plausibility on both sides. I have my problems with certain things. I have my agreements with certain things. I just don't like jackasses, I guess. Some people are so pious that they think their opinions are so right that they couldn't possibly be wrong on something. And that's generally reserved for youth. As you get older, you realize, I might be wrong on something, but let's see what the origins of the universe, the origin or origins of the universe is about. I don't know. I haven't seen this thing. I just grab things and then I sort of like react. I just think, give my thoughts on the fly. Let's see what this one's about.
The universe is everything, from the tiniest particles to the largest galaxies to the very existence of space, time, and life. But how did it all begin?
Here we go.
The origin of the universe is the origin of everything. Multiple scientific theories, plus creation myths from around the world, have tried to explain its mysterious genesis.
True.
However, the most widely accepted explanation is the Big Bang Theory. The Big Bang Theory states that the universe began as a hot and infinitely dense point.
Singularity.
Only a few millimeters wide, it was similar to a supercharged black hole. About 13.7 billion years ago, this tiny singularity violently exploded. And it is from this explosion, this bang, that all matter, energy, space, and time were created.
I've always wondered about that, though. If it was singularity and it was stable, how did it become unstable to poof, to go? Maybe something that was one trillionth, slightly unstable, infected the whole thing. But I always wondered about that singularity, because it would have seemed to have been incredibly stable.
What happened next were two major stages of the universe's evolution. Called the radiation and matter eras, they're defined by key events that helped shape the universe. First came the radiation era, named for the dominance of radiation right after the Big Bang. This era is made of smaller stages, called epochs, that occurred within the universe's first tens of thousands of years. The earliest is the Planck epoch. No matter existed in the universe at this time, only energy and the ancestor to the four forces of nature, the superforce. At the end of this stage, however, a key event occurred in which gravity split away from the superforce. Next came the Grand Unification epoch, named for the three remaining unified forces of nature. This epoch ended when one of those forces, called strong or strong nuclear, broke away. Then, the inflationary epoch began, during which the universe rapidly expanded. Almost instantly, it grew from the size of an atom to the size of a grapefruit. The universe at this time was piping hot, and it churned with electrons, quarks, and other particles. Then came the electroweak epoch, when the last...
Wait, are they saying, physicists and cosmologists and mathematicians out there might know this, did this just say that in 10,000 years it hadn't yet expanded? It only went from that singularity to the size of a grapefruit? And then these other forces broke away, as they say, the strong force and gravity sort of broke away? whatever that means, and maybe preceded the expansion of matter, sort of drew it out. I hadn't even thought of it in that light before. I don't know if that's what she just said.
Two forces, electromagnetic and weak, finally split off. During the next stage, the quark epoch, all of the universe's ingredients were present. However, the universe was still too hot and dense for subatomic particles to form.
Yeah, okay.
Then, in the hadron epoch, the universe cooled down enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear epochs, the radiation era's last two stages, the protons and neutrons underwent a significant change.
Oh, this is only 1 second. I didn't see that. All right. The lepton epoch, temperature 10 to the negative 12th Kelvin. Oh no, if it's super hot, it would be 10 to the 12th Kelvin, not negative. All right. And then time after the Big Bang, it's theorized, was 1 second. Then you go into the nuclear, 10 to the 9th Kelvin. That's still extraordinarily hot. Time after the Big Bang, 100, so a minute and a half or so. We're in the nuclear era.
They fused and created nuclei. And in doing so, they created the first chemical element in the universe, helium.
Yeah, then hydrogen.
The universe's new ability to form elements, the building blocks of matter, cued the matter era. Much as the name suggests, the matter era is defined by the presence and predominance of matter in the universe. It features 3 epochs that span billions of years, the vast majority of the universe's lifespan, and includes the present day. The first was the atomic epoch. In this stage, the universe's temperature cooled down enough for electrons to attach to nuclei for the first time. Called recombination, this process helped create the universe's second element, hydrogen. This hydrogen, along with helium atoms, dotted the universe with atomic clouds. Within the clouds, small pockets of gas may have had enough gravity to cause atoms to collect. These clusters of atoms, formed during the galactic epoch, became the seedlings of galaxies. Nestled inside those galaxies, stars began to form. And in doing so, they cued the latest and current stage of the universe's development, the stellar epoch.
The diaspora of
The formation of stars then caused a tremendous ripple effect and helped shape the universe as we know it. Heat within the stars caused the conversion of helium and hydrogen into almost all the remaining elements in the universe. In turn, those elements became the building blocks for planets, moons, life, everything we see today. This ecosystem of everything was only possible because of the many stages in the universe's development. While countless questions about the origins of our universe remain, it's only a matter of time for some long-sought answers to emerge.
I think National Geographic put that one out. That was a good quality video. Whether you agree with the contents or not, if you're a theist or believe, say, in the strict biblical construction that the Earth is 6,000 years old, then of course this wouldn't be something that would work for you. But one thought struck me during this: in the atheist, theist, or atheist, religionist, or believer, non-believer, called that in God, debate, is the singularity point is probably just as difficult to believe in it as to conceptualize, to understand, as it is for the theist to believe in God. Because both we can't conceptualize them. We can't relate to them. We can't even experience them in the way that we experience daily life, for example. And if we take Sir Karl Popper's falsifiability principles, the 5 steps, you have to be able to duplicate things, replicate them, and be able to test them We can't test God, we can't test the singularity. Neither is. So on certain scientific principles, even each is equally difficult to claim to know. And that's where in some senses it comes to be believability. Where's your faith, if you will? What do you believe? What makes more sense to you? The infinite density has an attraction to it. The way in which Planck had postulated and others have postulated, the expansion, the microwave, the background radiation that we're learning from, and all the different things that play into it. The 1 second after the quote unquote Big Bang, then 100 seconds after, and then 200 million year, 50,000 to 200 million, up to the billions now that are theorized. That'll continue to grow and change, and different theories will be challenged. And there are many people in the scientific field that are trying to make a name for themselves. And one way to make a name for yourself is to challenge an accepted theory and say, look, here are the problems with it. This explanation accounts for more of what we see across different disciplines, whether it's biology, chemistry, physics, all these things. The more it can explain, the better the theory is. And so things do change. But that singularity is beyond fascinating. And how gravity was viewed as something separate, like it's separated for the strong force, the weak force. They separated. It's like, all right, I can run with that to try to understand what that even means, because I just see gravity as integral, for example, to everything that exists in the universe. And even gravity itself is an interesting concept, as we know, and how it's presented in various ways in physics. But this was, all right, the origin of the universe. This wasn't just about, it was about what happened with singularity, then the expansion, then cosmic inflation, and what that looked like. So I do like how more detailed, if you will, this is. And you could look at each premise, and this is exactly what people do in their respective fields. Will look at each premise and say, that one's flawed, or it's incomplete, or it's just wrong. Here explains it better and keeps coming out. James Webb is discovering things that are challenging certain theories and such. But this is just fun to contemplate. Just is. Whether you believe in God or not, this stuff is straight up fun. So, all right, guys, leave your comments on this. It's, try to be nice in your comments. Even if you disagree with somebody, there's nothing that says that we have to be douchebags about it. So that was my idea. All right, folks, leave your comments. Subscribe if you haven't. That'd be wonderful. Have a great day. I'll see you on another video. Keep thinking theology.